Dear friends, last class we have discussed about basics of microcontrollers. We have seen the architecture of a basic block diagram of computer, the type of architecture like CISC and RISC, and again type of architecture like von Neumann and Princeton architecture. This class or this part of the video is about data representation. We know that in computers, data are represented by in form of zeros and ones, and can be fixed number of bits or can be variable number of bits. And if it's an n-bit storage computer, can store up to 2 raised to n distinct entities. So depending on the size of ALU or size of the processor, word size of the processor, we can have 8-bit, 16-bit, 32-bit or 64-bit architecture. And even numbers can be represented in two forms. One is unsigned and signed numbers. Unsigned numbers means numbers that can be used to represent both 0 as well as positive numbers, whereas signed numbers can be used to represent 0, positive and negative numbers. And also we know that the computer memory location stores, whatever be the pattern, it stores information as a binary pattern. So how this is interpreted, that is depending on the programmer, that's how it is going to be used. So it can be, suppose it is 000 or 001, it can be 1 if it is represent decimal notation. It can have some other meaning based on the type of notation that you are going to use. So this type of interpretation of binary pattern is referred to as data representation or encoding. Now integers in computers are whole numbers or fixed point numbers with a fixed point, that is radix point fixed after the least significant point. In contrast, we have floating point numbers where the position of radix numbers varies. It is not fixed. So that is how we have two types of representation like fixed point and floating point numbers. In fixed point numbers, we use bit length for representing numbers, can be like 8-bit, 16-bit, 32-bit or 64-bit used to represent the numbers. Besides bit length, we have two representation for integers. One is unsigned integer and other is signed integer. In the case of unsigned, we know that it can be used to represent both 0 and positive, so that you are all familiar with. For example, if you are using 3-bit representation, so 0 stands for 000, decimal number 1 is represented as 001, 2 as 010, etc., etc. So that all of us are familiar with. Now we go to the signed representation, which is used to represent 0, positive number, as well as negative number. This, if it is a negative number or positive number or 0, we can have three types of representation in signed scheme. One is signed magnitude scheme, second one is signed ones complement scheme, and third one is signed twos complement scheme. So in all please do remember that in all the three schemes, like it is signed magnitude or signed ones complement or signed twos complement representation, the representation of positive numbers is unique. For example, if you are representing +4 using 4 bits including sign bit, whether it is signed magnitude representation or ones complement representation or twos complement representation, the representation is going to be 0, 1, 0, 0, 0. So the first 0, LSB 0 stands for the sign bit, that is a positive 0 stands for positive, and the subsequent 3 bits indicate the magnitude. So whether it is, whether in all the three schemes, positive numbers representation is unique, 0 followed by the binary representation of the magnitude of the number. That's how it is represented, used for represent the positive numbers. And if it is negative number, there is the difference coming. For signed magnitude representation, if you want to represent a negative number, the representation is the take one's complement of the corresponding positive number. That's only what you remember. You know the positive number representation, just take one's complement of the one's complement of the corresponding positive number, that is a representation in one's complement scheme. If it is signed magnitude scheme, the sign bit changes to 1 and all other bits will be retained as such. So if negative numbers are represented by signed magnitude scheme, MSB will be 1 and other 3 bits represents the magnitude. If it is 1's complement scheme, for representing negative numbers, you just take 1's complement of the respective or corresponding post number. Similarly, for 2's complement notation, the representation is going to be 2's complement version of the corresponding post number. So let us see how it is. We take an example. Suppose you are going to represent, say, plus 5 in all the 3 schemes using 4 bits. So the representation is 0, that is the sign bit, 1, 0, 1. So if it is sign magnitude scheme, whether it is 1's complement scheme or it is 2's complement scheme, the representation of positive 5 is going to be 0, 1, 0, 1 itself. No change. Now, if it is minus 5, the representation is for sign magnitude scheme, MSB becomes 1 and other 3 bits remain the same, 1, 0, 1. This is minus 5 representing sign magnitude. If it is 1's complement representation for minus 5, just take 1's complement of the respective post number. So 0, 1, 0, 1, take 1's complement, 1, 0, 1, 0. If you want to represent minus 5 in 2's complement notation, you need to take 2's complement of the corresponding post number. So 0, 1, 0, 1 is the representation for positive 5. Go for the 2's complement. We have 1's complement as 1, 0, 1, 0. Take 2's complement is obtained by adding 1 to the corresponding positive number. So it will be 1, 0, 1, 1. So this is how my negative numbers are represented. There is a confusion between 2's complement and 1's complement scheme regarding arithmetic operation representation. This is just the representation. So negative numbers are represented by the 3, or sign numbers are represented by using 3 schemes. So you have seen the difference. In all the cases, the MSB will be 0 for positive numbers and MSB will be 1 for negative numbers. And how you get the representation, that is clear here. For positive number sign magnitude scheme, it MSB is 0. For negative numbers in sign magnitude scheme, MSB is 1. And other bits represent the magnitude for sign magnitude scheme. If it is 1's complement scheme, representation of positive number is unique, whereas the negative number is obtained by taking 1's complement of the corresponding positive number. Similarly, for representing 2's complement, in 2's complement scheme, we need to take 2's complement of the corresponding positive number. That's how the representation goes. Now, let us see another example. So, we'll consider plus 7 and minus 7 in 3-bit representation. In 4-bit, including sign bit is 4-bit. So, plus 7 will be represented as 0, 1, 1, 1 in sign magnitude scheme. It is again represented as 0, 1, 1 in 1's complement scheme. It is again represented as 0, 1, 1, 1 in 2's complement scheme. Coming to negative 7, it will be 1, 1, 1, 1 in sign magnitude scheme. It will be 1 followed by 000, taking 1's complement. 1 followed by 000 in 1's complement scheme, and 1 followed by 001, taking 2's complement in 2's complement. This is the representation for minus 7. We'll consider one more example. It's very important. So we are going to represent plus 0 and minus 0 in the 3 schemes in 4 bits. So plus 0 representation in 4 bit will be 0, 0, 0, 0. Sign magnitude scheme. 1's complement also 0, 0, 0, 0. 2's complement also 0, 0, 0, 0. That's clear. Now if minus 0 is to be represented by sign magnitude scheme, MSB becomes 1 and 3 followed by 3 zeros. And if it is in 1's complement scheme, you have to take 1's complement of corresponding post number. So you get as 1 followed by 111. And if it is for 2's complement representation, you have to go for 2's complement representation as 0, 0, 0, 0. Take 2's complement. 1's complement is here. Then add 1. So you get 0, 0, 0. This is very important. And this shows which number or which scheme can be used to represent negative numbers. So we know that plus 0 and minus 0 basically carries no difference. Both are unique. And that unique representation you will get only with the 2's complement scheme. 0, 0, 0, 0, 0, 0, 0. Whereas for sign magnitude as well as 1's complement scheme, representation of plus 0 and minus 0 are distinct, and that should not happen. And this is one major reason why only 2's complement notation is used in computers, because the important reason being representation of plus 0 and minus 0 is unique. I think it's clear to you. Now let us go to the presentation part. So for sign magnitude scheme, I have seen that sign magnitude scheme, drawback of sign magnitude representation. There are two representations for 0 that you have seen here, and another is positive and negative numbers to be processed independently. If it is one's complement representation, that also we have seen here, the drawback being representation of plus 0 and minus 0 are distinct, that should not be there, and similarly the processing is different for both positive and negative numbers. Coming to 2's complement scheme, I told you that representation for plus 0 and minus 0 is unique. That is why it is used as the number representation in computers. And another one more advantage is there that positive and negative numbers can be treated together in addition and subtraction, and also subtraction can be carried out using addition logic. So for mathematical operation, for negative numbers, using 2's complement will be most convenient or more convenient than other two schemes, because you just need to neglect the carry in the case of 2's. So these are the two reasons why in computers we prefer 2's complement notation. So students generally has a confusion between the representation. Suppose the question is that confusion is there. Some confusion is there regarding the representation of these numbers. For example, so the question is represent plus 5 in 2's complement. Suppose one question. And another question is, what is 2's complement representation of 0, 1, 0, 0? What is 2's complement? So 2's complement representation 0, 1, 0, 0 is 1. For 1's complement is 1, 0, 1, 1. And add one more 1. So you get 1, 1, 0, 0. This is 2's complement representation of 0, 1, 0, 0, or otherwise we can say plus 4. 2's complement representation of plus 4 is 0, 1, 1, 0, 0. If you are asked to get the 2's complement of plus 4, you are asked to get the 2's complement of plus 4, the result is like this. And suppose the question is to represent plus 4 in 2's complement notation, the confusion should not be there. You are just asked to represent plus 4 in 2's complement notation. So the answer is 0, 1, 0, 0. Sometimes students may go for 2's complement of this one. That is not the question. Represent plus 4 in 2's complement notation. The answer is 0, 1, 0, 0. No need to any other addition or something. And if you are asked to get the 2's complement form of, or get the 2's complement representation of 0, 1, 0, 0, then the answer is 1, 1, 0, 0. So this is going to be the 2's complement of this. That does not mean that this is plus 4. Whereas representation of plus 4 in 2's complement scheme is like sign magnitude or 1's complement. So this is the confusion there with all students. So that please make convinced with this representation, representing numbers, sign numbers using 2's complement notation, because while you coming to microcontrollers, microprocessors, etc., there all we have to use integers and its mathematical operations, and whenever negative numbers comes in computers, we prefer only, or we use only 2's complementary notation because of these two reasons. So we'll have the continuation of this video in the part 3. Thank you.